A very good morning to all of you. In this session of CAT mensuration, we are going to basically look at a few questions, a few type of questions which has come in the very recent CAT papers, and these will actually give us some idea about what questions to expect in the future. These are very recent questions, and so without wasting any time, let's start the discussion. Okay, so there is a very important concept for CAT mensuration, a very important concept, that is frustum of a cone. So when you have a cone and when you slice it at a certain height below the top, so the top becomes a smaller cone and the bottom becomes frustum of a cone. So that is a topic which has come in CAT many times. So what we'll do is we'll just have a look at a couple of very recent questions from the topic frustum of a cone. So basically this question which I am showing you, this is from CAT 2020 slot 1. CAT 2020 slot 1. So the question goes like this, that the height of the cone is 27 and the slicing is done at 9 from the top. The height of the cone is 27, but the slicing is done at 9 from the top. And you are basically getting two volumes. One is the upper one, which is a smaller cone, smaller than the original cone, and then you are getting the frustum. Now the question that came in the exam was that if the difference of this volume and this volume, okay, right? So if the difference of the bottom volume and the top volume is 225 cubic units, then what is the volume of the original cone? This is a question which came in CAT 2020 slot 1. Very typical frustum question. Frustum, I am again saying, very important topic. Simple. Whatever will be the ratio of the height whatever will be okay, so basically the concept is very simple. The ratio of the heights, it will be the same as the ratio of the radii of the bases. That is the concept, right? Actually, that concept also comes from similar triangles, but let's not make up new stories over here. We are stuck with CAT mensuration, so let us not bring in stuff like similar triangles unnecessarily. So the point is that the ratio of the heights is 9 by 27, that is 1 by 3. So if the small radius is smaller, big radius is bigger, so this radius will also be 1 by 3. This is the basic concept of frustum, right? The ratio of the height will be equal to the ratio of the radii, the small one to the big one. This is the basic concept. Now the thing is that suppose, let us say that the total volume, right? The total volume is V. Let us say that the total volume is V. Now you know that the volume of a cone is 1/3 pi r square h. The volume of any cone is 1/3 pi r square h. And you know that smaller and bigger, the ratio is 1/3. So smaller square and bigger square ratio will be 1/9. correct? Okay, you know that the height ratio is 1/3. So smaller square by bigger square will be 1/9. Height ratio is 1/3. So if you take 1/3 pi small r square into small h and 1/3 pi bigger square into big H, the ratio will be 1/9 into 1/3, that is 1/27. That means what? If the total volume is, let us say, 27V, so this volume will be V and this volume will be 26V, right? I'll repeat again. See, the ratio of smaller and bigger is 1/3. So the ratio of smaller square and bigger square will be 1/9. The ratio of heights is 1/3. So the volumes ratio 1/3 pi smaller square into small h by 1/3 pi bigger square into big H. It will be 1/9 into 1/3, 1/27. So if the full volume is 27V, the top will be V and bottom will be 26V. And it is given that 26V minus V is 225. So V will be 9. So 27V will be 243. So this is the way to do the CAT 2020 slot 1 question. The question was what is the volume of the total cone, and the answer is 243, right? So let's have a look at another question which came in CAT 2018 slot 1. So in this question, this is also from the topic frustum. In this question, the heights are 3 and 12. Okay, the heights are 3 and 12, and the radii are 1 and 4. Okay, so the heights are 3 and 12 and the radii are 1 and 4. So here you can see that the height ratio is 1/4, and smaller by bigger is also 1/4, right? Now in this case the question was you have to find the volume of the frustum. The question that came in the exam, this is the scenario, you have to find the volume of the frustum. This question came in CAT 2018 slot 1. So how do we find the volume of the frustum? So we will do 1/3 pi bigger square into big H minus 1/3 pi smaller square into small h. So you can take 1/3 pi common, and 4 square into 12 minus 1 square into 3, right? Because bigger is 4. So 4 square into 12 and 1 square into 3. So 1/3 pi. So this will become 3. So this will become 1/3 pi into 192 minus 3, right? And that is coming to, after simplification, it is coming to 198, because you have to put pi as 22/7. So the answer of this question was 198. So these are the two questions, very recent two questions which have come in CAT based on the concept of frustum. CAT 2020 slot 1, CAT 2018 slot 1, right? So basically, let's summarize the concept. First concept is that whenever you slice the cone, then whatever is the height ratio, same will be the radius ratio. That is concept number 1. And concept number 2 is that when you need to do a specific calculation like difference of volumes, then you just set up the formula 1/3 pi r square h and do it. And when you have to do a ratio based calculation, then also it's pretty easy. You just have to remember that whatever is small r by big R, the square of that you have to take, and whatever is height ratio you have to take it as it is and multiply small r square by big R square into height ratio. That will give you the volume ratio. So this is a very, very important topic that has come in CAT recently 2 times, and it has come before that also many times, right? A very important question, that is how to deal with frustum of a cone. Okay, now let's move on to another type of question which has come recently. This is from CAT 2020 Slot 2 paper. Another recent type of question, that is pyramid. Now pyramid is a very uncommon thing. We don't normally encounter pyramid. Why? Because in many ways pyramid is like a cone, but the only thing is that instead of a circular section, the section is a square. So exactly you visualize a pyramid. All of us have some idea about pyramid. So the pyramids of Egypt, for example. So the pyramids of Egypt, for example. So that means that the base will be a square. So there is a pyramid, right, and it has been informed that the base is a square of 20 by 20, okay, and the four faces are all equilateral triangles. This is the question. It is a question from CAT 2020 Slot 2, okay. So the base is a square of side 20, and the faces are all equilateral triangles. So what happens is that you will notice that this will be 10, because if I drop an perpendicular from the peak to here, and then if I drop a perpendicular like this will be 10. Now what I'll do is that I'll just join this one, okay. So this three-dimensional you'll have to visualize a little bit. So let me just give it a name. So let me call this O, A and B. So basically OAB is a equilateral triangle, right? OAB is a equilateral triangle. So I am dropping a perpendicular D. So OD will be root 3 by 2 into 20. So OD will be equal to 10 root 3. So OD is 10 root 3. So the question that came in the paper was that what will be the height of this pyramid. So 10 root 3 is OD, PD is 10. So the height of the pyramid will be root over 10 root 3 square minus 10 square. So that is 10 into root 2. So this was the question which came in the CAT 2020 Slot 2 paper, that the height of the pyramid will be by Pythagoras theorem 10 into root 2, right? So pyramid, very important concept. So how do we approach pyramid? Well, you will be usually given a pyramid with a square section. Some additional information might be given, like all the faces are equilateral triangle. So you will have to draw a diagram based on the information given, and mostly a little bit of geometry. As far as volume calculations go, you must have realized that if they ever ask volume of a pyramid, it will be 1/3 cross section area into height, just like a cone, right? So this is a question from a recent paper, 2020 Slot 2. Okay, now the thing is that The next thing that we are going to discuss is, by the way, before I continue, a very important thing, that whatever questions I am discussing with all of you, in the description box below there is a drive link to a PDF. So these questions you will get in that PDF, and in fact I would suggest that all of you try the whole PDF after this session is after you have seen this whole session. You try the whole PDF. You can even submit it to me for correction, right? There is a Google Drive link in the description box below, and over there you will get a PDF where these questions are given and some more questions are given. So you can attempt all of them after seeing this session, unless you have already attempted them. Okay, now the thing is that the next thing that we are going to discuss is that sometimes there are questions where they will tell you that you have 3 different volumes, and then you have to take the maximum common out of each and make some identical containers or something like that. So for example, this question came in CAT 2019 slot 2. There is this question that there were 3 different volumes of metal, like 405 cc, 783 cc and 351 cc. So this question came in the CAT 2019 slot 2 paper. The question was that there are 3 different volumes of metals available to you: 405 cc, 783 cc and 351 cc. Now the question that was given was that you have to make cylinders. Such that each cylinder has the maximum possible volume, right? And the volumes of the cylinders, they are all integers. And the other thing is that let's have a look at this. So 405 cc, I can write it as 5 into 3 to the power 4. 783, I can write it as 3 cube into 29. And 351, I can write 3 cube into 13. So 405, I can write it as 5 into 3 to the power 4. 783, I can write it as 3 cube into 29. 351, I can write it as 3 cube into 13. So if I try to do HCF, of these, so obviously the HCF will come to 27, right? If I do HCF, it will come to 27. So the question was that you have to make identical cylinders of maximum possible volume. So the maximum volume will be 27 cc. And how many cylinders will be there? So if you divide 405 by 27, you will get 15. If you divide 783 by 27, you will get 29. If you divide 351 by 27, you will get 13. So the number of cylinders will be 15 plus 29 plus 13, which is 57, right? So you have to make identical cylinders. So each of them will have a volume 27. And how many cylinders will be there? 57. Now the question was that what will be the total surface area? What will be the total surface area of all the cylinders? Right. Now the thing is that to attempt this question, you will have to say like this. There is another information given in the question that all the cylinders have a radius of 3. So pi into 3 square into h is 27. So h will be 3 by pi. So therefore the total surface area of the cylinders, it will be 2 pi into 3 square plus 2 pi. The total surface area of any particular cylinder will be 2 pi into 3 square plus 2 pi into 3 into height. You know the total surface area of a cylinder is 2 pi r square plus 2 pi rh. So it will be 2 pi into 3 square plus 2 pi into 3 into 3 by pi. This will be the total surface area of a particular cylinder, and meanwhile the number of cylinders is 57. So the answer will be 57 into this whole thing. So this whole thing is 18 pi plus 18 pi So 1026 pi is the answer. Okay. So basically this is a CAT 2019 slot 2 question. So what we had to do here was that there were 3 different volumes given and we had to find the HCF. So that became the common volume of each cylinder. Then using pi r square h equal to this 27, r was given as 3, we found out h, we found out how many cylinders are there, and after that we went for the exact calculation. And this is how you have to do this particular question, right? So this is an example of the kind of question where you have to take HCF of certain volumes to get the maximum volume of identical shaped objects. Like here you have to get identical shaped cylinders, right? Okay, then one of the most important topics in recent times that has come in CAT, one of the most important topics is regular hexagon. Regular hexagon is considered a very important kind of a question. You will find that there are many instances of questions on regular hexagon. Now suppose this is a regular hexagon. Let's say this is a regular hexagon. Now you have been told that corners have been cut off from an equilateral triangle. Okay, okay, so there is an equilateral triangle and corners have been cut out of this equilateral triangle to create a regular hexagon. So basically the way to do this kind of question is that basically these are the sides of the hexagon. So suppose each side of the hexagon is A. Let's say each side is A. So in that case these will also be A, because this angle is 120, this angle is 120, so these two will be 60-60. So these two will be A, these two will be A, so all of these will be A. Now the question is that came was, what is the ratio of the area of the hexagon? Okay, the ratio of the area of this hexagon to the area of the equilateral triangle. So it will be 6 into root 3 by 4 into a square divided by root 3 by 4 into a square. So 6 into root 3 by 4 into a square divided by root 3 by 4 into a square. So therefore root 3 by 4 into 3a square. So this is coming 6a square by 9a square. So it is coming 2:3. So this is the question which came in CAT 2019 slot 1, right? So this is a question which came in CAT 2019 slot 1, that what is the ratio of the area of the hexagon to the area of the whole equilateral triangle. So this is the area of the hexagon, this is the area of the equilateral triangle, and so you can see that the answer is 2:3. Let's have a look at a slightly different kind of question based on hexagon. So this was one example. Let's have a look at another one. So CAT 2017 slot 2. Okay, basically this question was an easy question, but I'll just give you some background. I'll tell you the question, okay, but I'll give you some background first. So basically ABCDEF is a regular hexagon, right? I'm just giving you some background. So in a regular hexagon, suppose each side measures 1 unit. Suppose you have a regular hexagon and each side measures 1 unit. So you understand the word diagonal. Diagonal is join of 2 points other than the actual sides of that figure. Okay, so if you join AB and BC, if you join AB and if you join AC rather, you will get a diagonal. If you join AD, you will get a diagonal. So suppose AB is 1, BC is 1, so AC will be root 3 and AD will be 2. So remember, there are 2 kinds of diagonals in a hexagon. So the largest diagonal is this, that is 2, and the other diagonal is this, that is root 3. So these are the 2 measurements, and the actual question which came in the 2017 slot 2 paper is you have to find AC square. So obviously that's an easy one. You can see that AC square is 3, right? So just try and remember this, that if the sides are 1 centimeter each, then one diagonal, the longest diagonal will be 2 and the other diagonal will be root 3. So just remember like this, okay? Okay, now since we are on the topic of diagonals, so what is the other kind of situation where you can get a question based on diagonal? So this is actually diagonals of a cube. Now we are talking about a question which came in the 2019 slot 1 paper. Okay, we are talking about a question which came in 2019 slot 1 paper. So basically what happens is that, let's say you have a cuboid. Okay, a cube is an ideal cuboid in which all dimensions are equal. So let's say you have a cuboid. So in a cuboid, what is happening is that the length is L, breadth is B, and height is H. So in a cuboid you have 6 faces and you have 3 types of face diagonals. So the face diagonal, I've just drawn one of them. So this particular one, it will be root over B square plus H square. So all the face diagonals you can get by Pythagoras theorem. So this was a question which came in CAT 2019 slot 1, and the question was like this, that the face diagonals of a cuboid are given. So root over L square plus B square is 3, root over B square plus H square is 2 root 3, and root over H square plus L square is equal to root 15. So root over L square plus B square is 3, root over B square plus H square is 2 root 3, and root over H square plus L square is root 15. So these are all given in the question. You have to find the ratio of the shortest side to longest side. That was a question which came in CAT 2019 slot 1. So there is a cuboid, the 3 face diagonals measurements are given, and using this you have to find the ratio of the shortest side to longest side. That is a question. Okay. So from the first one we can say that L square plus B square is 9. From the second one, B square plus H square is 12. And third one, H square plus L square is 15. So if you add all of them, H square plus L square plus B square, you have to just add all of them. So it's coming to 18. And now you just go back to each of these and combine it with this. So from here you will get H square equal to 9. From here you will get L square equal to 6. From here you will get B square equal to 3. So H square is 9, L square is 6, B square is 3. So the ratio of the shortest side, so root 3, and longest side will be 3. So answer is 1 is to root 3. So this was the question which came in CAT 2019 slot 1. So the 3 face diagonals are given. You square all of them, add all of them to get a certain relation between H, L and B, and then you combine that one at a time with each of these to get H square, L square and B square, and you can see that the shortest will be root 3 and the largest will be 3, and the ratio is 1 is to root 3, right? And by the way, there is something called body diagonal of a cuboid also. And body diagonal is simply root over L square plus B square plus H square, right? Body diagonal of a cuboid, root over L square plus B square plus H square. Okay, now in very recent times, there has been a couple of questions based on area of a parallelogram. So generally in mensuration, area of parallelogram is not given much importance. In fact, area of some other quadrilaterals like square, rectangle, those are considered more important. But couple of questions have come based on area of a parallelogram. So let's have a look at that. So suppose you have a parallelogram ABCD, right? Suppose you have a parallelogram ABCD and the base of the parallelogram is given to be 8. So this was a question from CAT 2018 slot 2 paper. There is a parallelogram ABCD and the base CD is 8, and you have been told the area of the parallelogram is 48 square units. Okay, so there is a parallelogram, the base is 8 and the area of the parallelogram is 48 square units. The question was asked like this: what is the least value of this side AD? What is the least value of AD? Least value. That is how the question was framed. Now, there are a lot of ways to discuss this question. I will use trigonometry. Okay. In the process, we'll also get a chance to just do a bit of basic trigonometry. Okay, I will use trigonometry. There are other ways to do it. I'll use trigonometry. So suppose this angle is theta. Now there is a trigonometric function called sine. So sine is, suppose if I call this as AE. So sine is the definition of sine. It is opposite by hypotenuse. So sine is AE by AD. Okay, that is a definition. So the area is 48, so this will be 6. So 6 by S, right? So sine is 6 by S. Now sine is always lesser than equal to 1. So S is greater than equal to 6. So S will be greater than equal to 6. So that means the minimum value of AD will be greater than equal to 6, right? So what did we do? We used the very famous trigonometry concept that sine of any angle has to be lesser than equal to 1, and from there we found out that S has to be greater than equal to 6. So this was one question based on parallelogram area which came in CAT 2018 slot 2. The other question was again from CAT 2018, but it was from slot 1. So the question was that there is a parallelogram. There is a parallelogram in which the sides are 16 and 9. And the area of the parallelogram is 72 square units. So this was a question which came in CAT 2018 slot 1. There is a parallelogram ABCD and the area of the parallelogram is 72 square units. This is 16 and this is 9. So you know that area is base into height. So the height will be 8 because you know the area is base into height. So base is 9, so height has to be 8 because 9 8s are 72, right? Now the question which came in the CAT paper is that what is the area of triangle ADE? Okay, the question which came in the CAT paper is what is the area of triangle AD? This was a question. So basically you have got 16 and you have got 8. So if you do a Pythagoras, so 16 square minus 8 square root over, that is equal to 8 root 3. Okay, so this is 16, this is 8, so root over 16 square minus 8 square, so that is coming to 8 root 3. So the area will be half into 8 root 3. So So that is 32 root 3. So area of any triangle, best formula is half base into height. So half into base is 8 root 3, height is 8. So half into 8 into 8 root 3 is 32 root 3. So this is the answer of the question which came in CAT 2018 slot 1. So these are the two questions, very recent questions based on area of a parallelogram. There's only one formula to find area of a parallelogram, that is base into height. But in these questions, what was observed was that after you do the initial base into height, you have to do a little bit of something else, like maybe trigonometry, maybe Pythagoras, very basic stuff. But interesting that they are using area of parallelogram and adding on something to it to make questions like this, right? So important indicators for the future. Fine. And now I would like to wind up this session with a very interesting question. We have seen that in this question they asked us least value of S, and before this, much before this, in today's session, we had a question that you have to split three types of volumes, 405 cc, 351 cc, 783 cc, to make cylinders of maximum volume. And now we are going to have another question where we are going to again discuss this topic of maximum or minimum. So, but this one, the one we are going to discuss now, this one involves the very famous AM-GM inequality. Now see, AM-GM inequality is a topic which somehow sneaks in to the CAT paper through some chapter or the other. It is actually a part of the chapter sequences and series, but in the CAT paper it may just sneak in from some other chapter. Like, for example, let's have a look at this question from CAT 2017 slot 2. So in the CAT 2017 slot 2 paper, the question was like this. Actually the question was like this: there is a rectangle and these two are x and this is y. So the sum of these two sides, x plus x, and this side y, the sum of x plus y is given to be 400. Okay. And so you can do one thing, you can take 2x plus y by 2 and do greater than equal to root 2xy. So I am doing the AM-GM inequality, I am using the two quantities 2x and y. So 2x plus y by 2 is greater than equal to root over 2xy. Now the thing is that in AM-GM equality, the equal to will occur when the two quantities are equal. This is the basic concept of AM-GM inequality, that the equal to happens when the two quantities are equal. So the equal to will happen when y is equal to 2x. So if you put y equal to 2x, then x will be 100. So y is 200, obviously. X will be 100, y will obviously be 200. So we have got all the measurements, and in fact that was the question that came in the exam. The question was that you will have to find the measurements of the shorter and longer sides of the rectangle so that the area of the rectangle is maximum, right? So you know that root over 2xy is root over 2 into area, and that is less than equal to, so that means this is the maximum value of the area, but this will be equal to this only when y is equal to 2x. So the area of this rectangle will be maximum when x is 100 and y is 200. So this was a question from CAT 2017 slot 2 paper, that some information was given and you were told that the area of the rectangle is maximum. So when the area is maximum, you have to apply the condition for AM is equal to GM, and from there you can get the dimensions which you desire. So they had asked for the shortest and longest side of the rectangle, and you can see that you are getting it, right? Okay, so basically the purpose of this session was not to give you a long drawn lecture about all the formulas of mensuration. In various other sessions we have already done that. What I really wanted to highlight in this session was the kind of questions which have come in the recent CAT papers, and so basically just to give you some pointers, summarize like this, that AMGM inequality, very strong candidate for the future. You are very likely to get it in some other chapter, so you can get it in mensuration. Area of parallelogram, okay, important applications from their area of parallelogram. Then pyramid, so you have to keep your eyes on that because pyramid requires a diagram, you have to draw it and get the answer. Pyramid is important. Then hexagon, very important topic for CAT mensuration. Again a very important question for the exam first term. So basically I think we have covered some ground, and there is a PDF in the description box below. You can just access the PDF and you can try the rest of the questions. Some of them I have done with you just now, the rest of them you can try. All of them are from recent CAT papers, and I'll be posting similar videos for other chapters as well. Okay, that's it. Thank you. Bye all of you.